Hello everyone, welcome to Big Data Thoughts. Today we will talk about two data formats which are widely used, Parquet and ORC, and we'll try to see what is the difference between both or what are the advantages, because this is a common topic which many people find difficult in terms of explaining either in interviews or for themselves to understand and choose which format will work better. So let's get started. So let us first start with what is the Wild West era of data, or what is the difficulty to start with when we talk about big data. So we all know data is scattered across different formats. It is inconsistent, messy, hard to query, so it is very difficult to analyze. The data that we receive may not be of quality, may not be in a structure that we want. So it needs a lot of manual wrangling, repeated cleanings, and that slows down the overall progress. So there are definitely challenges when we are talking about huge amount of data, and how do we even bring it to a stage where analytics can be done over that data. Fat file and simple databases, why they fell short. So it is also important to understand why are we even talking about these kind of file formats like Parquet ORC in the big data world. Where did the flat files that we had earlier or simple databases for structured data fell short? So earlier people used to have CSVs or text-wise relational databases, and they worked really well. But when the data started exploding and there were billions of rows and unstructured data, these relational databases or CSVs are not um, going to scale. So that is when the storage and performance bottlenecks made the scaling really impossible. The databases could not scale to the demand of the ever growing volume, or and also they could not scale up to process that kind of data. The schemas were rigid. The databases were schema on write, which means the schema was predefined and the data had to be fit into that schema. That was the limitation of flat files or simple databases. So, new technologies had to come up to cater to the needs of the big data. So, all of these problems that I described gave rise to the need of a different kind of a platform for storage as well as compute. That was the renaissance of data. So there, with new technologies, with advances in hardware, there is an explosion of data from multiple sources, and it is also leading to multiple formats. So when data is coming in different formats and in huge volumes, and the need is to process in real time, how do we send the data across the network? So what we have to do, we have to definitely look at different kind of file formats which are more efficient and optimized for big data kind of situations. These formats like Parquet, Avro, ORC became the foundation for modern analytics to have that speed and interoperability that these kind of big data environments need, because these files were speedy, they were compressed, and they were interoperable. So these few slides that we look at, the intent was to understand why even a format like Parquet, Avro, ORC is needed. What was the challenge? Why the databases used earlier, which were very efficient, could not scale now? And what was the need to have such file formats? Now, earlier, one more factor that we have to know is earlier we were doing descriptive kind of analytics. Then from there, descriptive means we can just tell what happened. We gather data, we analyze, and we give a descriptive analysis saying that this is what happened looking at the data. But the analytics world also changed and evolved. There was a need to do predictive analytics, which means looking at the data that I have, I need to predict what will happen now. And then it evolved to become prescriptive. What does that mean? That means from analyzing what happened to analyzing or predicting what will happen, and then going to prescriptive, which means telling what to do when something happens. So it's like a evolution of analytics also, in terms of how we are analyzing the data or representing it. And to do all of this, we have to have efficient data storage, compute, and handling of data. Okay, there are of course evolutions in AI and ML space also. So with all of these shifts in the storage world, hardware world, data world, analytics world, it definitely needs newer kind of file formats and technologies. Okay, now let us look at these file formats that I spoke about. The columnar powerhouses. These are all columnar formats, or let's say columnar powerhouses. How did they emerge? Okay. Now, when we think vertically, why I'm saying vertically? Because initially the relational databases or the flat files, they were all traditional row-based storages. The data was stored row-wise. It was very efficient when we talk about transactions, but it is not efficient for analytics or analytical use cases, or use cases where we only want to look at few columns out of the entire data. The data may have 500 columns, but I'm not interested in the entire row or 500 columns. I want to do analytics on few select columns. So then this kind of traditional row-based storages will not help. They will not be efficient in storage as well as compute. So then this whole perspective changed from moving from rows to columns, right? The columnar storage came in. And why it matters? Because now the scans are faster, the compressions are better because you're grouping columns together. You're doing faster scans because you're not storing row wise and scanning the whole row when you need only few columns. So this gave a huge performance boost for analytical queries, and this is the fundamental to understand file formats like Parquet ORC. They are all column based file formats. Now let's talk about Parquet first. What is the USP of Parquet? It is a cross-platform champion. What does it mean? It can be used across platforms. This Parquet file format was inspired by Google's Dremel. So Google came up with Dremel and wrote a paper on that. And this was the basis of their big query. And that's when later on Parquet came in. Dremel were designed for massive scale. It was optimized for parallelism because we are talking about a distributed architecture and a big data world. So definitely parallelism is needed. Schema is going to evolve with time. So we definitely need something where schema evolution is possible. And there can be nested data because data is complex and in multi formats. That's where Parquet was designed to have all of these characteristics based on Google's Dremel or inspired by Google's Dremel, let's say. It is widely adopted in Spark, Hadoop, Presto, Snowflake, all different kinds of technologies that we hear about. They all mostly use Parquet. In industry, if you see, there are few formats which are very prevalent. One of them is Parquet. What is the biggest strength of Parquet file format? It is its compression ratio, the speed and interoperability across ecosystems. That is where Parquet shines. Now, ORC. What is ORC? ORC was primarily used with Hive and Hadoop. It was very optimized for Hive and Hadoop. It was created by Apache to basically give boost to Hive queries and Hadoop distributed file system. It was very optimized for predicate pushdown. Predicate pushdown means we do the filtering of the data or we skip irrelevant data. It has strong compression and indexing, which helps in big data situations. And but one note to call out here, it was meant for Hive and HDFS kind of combination. And what is the legacy that was built by Parquet and ORC? These were the most prominent file formats used. Now, together, Parquet and ORC both are very optimized or good for big data analytics. They became the backbone of data lakes, warehousing, and model ML pipelines. Both of these file formats represent the unseen infrastructure that is making today's queries possible. All the lightning fast queries are possible because of these optimized, compressed, and fast file formats. Now let us do a deep dive into Parquet and then we'll deep dive into ORC. So as I said, what are the most salient features of Parquet or secret weapons? The first and foremost is schema evolution. It has a flexible structure that can adapt to growth, changing data models without breaking the old queries. Now, one thing, you cannot read a Parquet file with your naked eyes, just like you can read a CSV or a text file. You need a program to read, or most of the times the tables are pointing to a maybe external location where a Parquet file is kept, right? That's how it operates. But you can either query through a table, you can use a program, but you cannot read it through your naked eye. But the salient feature of Parquet is schema evolution, because in this big data world, it is ever changing. Schema will evolve, and we don't want a file format which will break for older queries because the schema has changed. So, the biggest weapon or USP of Parquet is schema evolution. Optimized compression. Parquet is optimized for compression. It groups similar columns. As I said, it's a column based or columnar format, which means it will group columns together rather than storing each row together. It stores columns together, which will reduce your storage cost, which will reduce your querying cost. Predicate pushdown is another thing. It skips all the irrelevant chunks of data by applying filters early on at the time of compute. So, three things are the USPs of Parquet: schema evolution, optimized compression, and predicate pushdown. What is the area where Parquet shines the brightest, or where should it be used? When we are talking about complex analytics, where we are having wide tables, nested structures, huge query scans, that is where Parquet will give us efficiency in terms of compression, in terms of speed and storage. If there are wide tables, meaning the ones where you have too many columns, huge wide tables. Machine learning pipelines where you want to do fast read and selective access, their data lakes at scale, the backbone format for cloud based platforms, any of these, if you see S3, Azure Data Lake, GCP, most of the cases, people in production are using Parquet as a file format because of its efficiency in terms of storage speed and compression. What are the real world examples? Netflix, Ubers of the world, Airbnb of the world, they all rely on Parquet, and they have workflows written in Spark. Right? Different tech stacks are used by different people, but Parquet is what is being used by many of these industry giants. Okay. Now coming to ORC. ORC, what is the unique strength of ORC? One is ACID transactions. As I said, ORC was meant for Hadoop Hive combination. So it gives us very good ACID transaction capability. It ensures there is a reliability for insert, update, deletes, which are very, very critical for enterprise grade data warehouse kind of a use case. Vectorization, it processes batches of rows. It does not process one row at a time because it is processing batches of rows. It is very efficient in terms of speed. It has tight integration with Hive and very optimized for Spark. So it was meant for initially Hive and HDFS combination, but it can go very well with Spark execution. Where does it excel? It can excel in data warehousing kind of use cases where frequent updates, inserts, heavy SQL workloads are there, where highly structured queries are there, where there is a predictable and schema driven, then ORC works really well. In terms of HDFS and Hive ecosystems, though today you would see in production very few people may be using Hive and Hadoop as compared to what it was a decade back. But still, this works excellent with Hive Hadoop combination as well as Spark. And where all is ORC used? Banks, telecom, large enterprises with legacy Hadoop stacks, they still are using ORC, and it is very well suited for their use cases. Now, how do you choose where to use Parquet versus ORC? When should we use Parquet? When we need an ecosystem that is compatible with Spark, Snowflake, BigQuery, those kind of use cases. When you have read heavy analytical or ML driven use cases, or you need schema flexibility and cross platform portability, then you should choose Parquet. When should you choose ORC? ORC is a good candidate when you are using Hive Hadoop combination, when you need ACID guarantees, and when you have ultra optimized performance on structured SQL heavy queries. These are the cases where you should choose ORC, though you would see use of Parquet much more these days than ORC. What can be a hybrid approach? Because we are talking about modern architectures, only one thing may not work all the time. So organizations strategically use both the file formats. So ORC can be used, like I said, for enterprise data warehouses where you need transactional capabilities. Parquet can be used for ML pipelines, data lakes where you need scale and portability and schema evolution. Modern data platforms can have combination of both based on the use case. And what are the next for data formats, right? What are the emerging trends? So there are table formats that build on Parquet and ORC, which then add versioning, time travel, transactional consistency, like Delta Lake, Hoodie, Iceberg. These are all built on top of these kind of file formats, but they provide additional features like time travel and versioning. Vectorized formats and arrow integration. This can speed up our in memory analytics. Cloud native formats, which are designed for object storage and serverless query engine. These are also emerging trends. Then there are community contributions and evaluations. Open source communities will continue to enhance compression, predicate pushdown. There's a lot of work that happens in open source communities, as well as there are pioneers like Databricks who build a lot of features on top of Spark and give you flexibilities. So there is a lot of work going on. Formats are evolving. With every challenge that we face, there are opportunities identified, and then new data formats come in or new technologies come in so that the scale of data can be supported. But as of today, these are two very important formats which we should understand when we are operating in the big data world. The takeaways from this is that there is no single winner, either Parquet or ORC. They are complementary. Together, they lay the foundation of modern data ecosystem, and we can use them in conjunction. They are intelligent formats, right? We can use them in conjunction based on the use case. We can choose. So this is all about two very prominent file formats, Parquet and ORC. I hope this has helped you to understand the concept. Please like, share and subscribe to the channel to get more interesting videos. Thank you.